peak value and RMS value of AC. In alternating current or alternating voltages, you have two values. One is your peak value, another one is your RMS or root mean square value. Suppose this is your alternating current, the maximum value, this is the maximum value of the current. If this is your time and this is your current, then this is your maximum value of current, which is called peak value. And what is RMS value? In many instruments like your analog oscilloscope, in analog oscilloscope you can see the signal, AC signal or any signal, electrical signal. There you need the peak value. But when you need RMS value or root mean square value, suppose in electronic instruments, suppose take the case of rectifier. In rectifier, you can convert AC to DC. So here there is a need of the root mean square value. What will be the DC value of the AC? So today we will discuss what is the RMS value and how peak value is related to RMS value. RMS value means root mean square value. Why we take root mean square value? Because if you take average value of AC, then it will be equal to 0. The average value of AC will be equal to 0 because the positive half is equal to the negative half. So the average value of AC will be equal to 0. You cannot take the average value. So what we will do, if you take the square, if you take the square of the current, then you will get the current like this. This will be the square of the current, I square. So here if you take the average value, then it will not be equal to 0 because all the values are positive. Okay. So what do we do in RMS value? We make the squares of the current and divide by in. Suppose I1 square plus I2 square like IN square and divide by in, then this will be equal to mean square value. This is the square and this is the mean square value. But we need the average. If you take the square root of this mean square, then this value will be equal to or nearly equal to the average value of AC. So if we want to find out the average value of AC, then this is a trick. This is a trick to find out the average value of AC in electrical instruments. So how we will find out the RMS value of AC? RMS value of AC is also called the virtual value of AC. You can write IRMS or you may write IV. Sometimes it is also called IDC, DC value of AC. Okay. So what we generally take, AC and DC, they act in electric field or in electrical circuits, they act in a different way. If we allow electric current to pass through a conductor, if you allow AC to pass through a conductor, and to the same conductor if you allow DC to pass, then the behavior will be different. Similarly, the magnetic behavior of AC and magnetic behavior of DC is also different. But which behavior is same for both AC and DC? That is the heating effect. Remember, that is the heating effect. That means if you heat a conductor by means of DC and if you heat the same conductor by means of AC, in both the case the heating effect will be same. So if you compare the DC value of AC, what you will do? You will take the heating effect of DC and compare it with AC so that you can have a relationship between peak value and RMS value. That is why RMS value is defined as the amount of heat produced by DC by certain time through a resistor, which is equal to or same as the amount of heat produced by AC by the same resistor in same time. And it will be easier for you if you allow DC and AC to pass through the resistor for one cycle. This is the calculation, mathematical calculation. We know from the heating effect that heat produced by a conductor is given by the relation I square RT. So if you take the RMS value or DC value, then you will write for DC IV square or I RMS square into RT. R is the resistance of the conductor and T is the time. Suppose this is equation number 1. Now you allow AC to pass through the same resistance for the same time. Then how you calculate the total amount of heat produced in case of AC? If you take for a small interval of time, if you make the interval of time small, then what will happen? The current will be small, and we know the current is generally AC current. You do not denote it either by means of sine wave or cos wave. Suppose if you represent the current in sine wave, that is I equal to I0 sine omega t, then what will be dH for time dt? dH will be equal to I0 sine omega t square into RT. So it will be equal to I0 square sine square omega t R dt. And I0 square R is constant, you can take it outside. And as you know, cos 2 theta is equal to cos square theta minus sine square theta, or that is equal to 1 minus 2 sine square theta. So sine square theta will be equal to 1 minus cos 2 theta divided by 2. This is the standard formula in trigonometry. So from the standard formula you can write sine square omega t is equal to 1 minus cos 2 omega t divided by 2. And if you want to calculate the total heat produced in time t, in a time interval from 0 to t, or for one cycle, then this will be equal to I0 square R divided by 2, and integration of this factor you can do, you have taken to the outside. So 1 minus cos 2 omega t, integration from 0 to t dt. And this will be equal to, if you integrate dt, it will be equal to t, and if you substitute t minus 0, this will be equal to t, and integration of cos 2 omega t sin 2 omega t divided by 2 omega, and if you substitute t, then this will be equal to sin 2 omega t divided by 2 omega. And as you know, omega t is equal to twice pi, so this will be equal to sin 4 pi, and sin 4 pi will be equal to 0. So this factor will be equal to 0. So your result will be equal to I0 square RT divided by 2. So heat produced by the AC in the same time t or in a time period t is equal to I0 square RT divided by 2. Suppose this is equation 1 and this is equation 2. And you compare, when you applied DC, the heat produced is equal to this much, and when you applied AC, the heat produced will be equal to this much. So if you compare the two equations, then IV, virtual value of current, or RMS value, you can write I RMS, or you can write IDC, IRMS is equal to I0 divided by root 2. That means the RMS value of AC is equal to 1 by root 2 times of its peak value. Suppose the peak value in a AC is equal to 311. If the peak value is equal to 311, peak current is equal to 311 ampere, then what will be its RMS value? Just divide by root 2. It will be equal to around 220 ampere. So, it is a very interesting thing to know about RMS value and how it is related to peak value. You do some problems on it, and if you have any doubt, you write to me in the comment section. Thank you.